Okay, this is the last lesson ever that I will teach y'all this year. And I finally found the microphone packed up in boxes, so hopefully it's a better sound quality than before. All right, today's lesson is C.6, Solving Systems with Conic Sections. So we are actually going to do them algebraically this time, but I wanted to show you graphically what's going on, and I'm going to try to reinforce that as we go through. So keep in mind, as you solve these equations, this picture right here shows you the possibilities that you can have if we have what is called a linear quadratic system, which means one of our equations will be a line and one will be a quadratic. So keep in mind that the solution to the system is all the points they have in common. So clearly you can see that this one has 0 solutions. This has 1 solution, and this will have 2 solutions because it has 2 points of intersection. So we're going to concentrate on algebraic methods, and that means we're going to be using substitution or elimination to solve. So look at this first example. Solve the system of equations. So really what I want to do, when you look at this, 3y plus x squared minus 4x minus 17 equals 0, you should be able to tell me what that is, the graph of. There is only one variable that is squared, that is x, so that means it's a parabola, and if x is squared, it's going up or down. And if I put the x's together and move the y to the other side, it will be negative, so that's how I know this parabola is going to be going down. And here we have a line. If you want to solve it for y, you could do negative a over b to find its slope and know that it's going to have a positive slope. Okay. So how do you want to solve this? Elimination tends to be easier. So if you can eliminate a variable by adding or subtracting the equations, that's the easier way to go. So when I look at this, if I subtract the top equation minus the bottom equation, then you see that the y's will fall out and all I'm going to have left are x's. So that's what I'm going to do. And when I do that, I'm going to have x squared plus 6x minus 55 equals 0. Okay, whoops, sorry about that. So I've got to factor that. That is, of course, x plus 11, x minus 5. So that means that x equals negative 11 or 5. So then I'm going to take each of those points, and you can put it into either one, y'all, but I would pick the one that is less complicated. Okay, so I'm going to take it and go plug it into that bottom one. And when I do, the first time, I'm going to have negative 3y minus 10 times something. I'm plugging in negative 11 plus 38, and that's going to give us 3y equals negative 148, and y equals negative 148 over 3. And then I'm going to go do that again. Okay, this time, instead of negative 11, I'm going to plug in 5, and that's going to simplify to 3y equals 12, and y equals 4. So keep in mind, y'all, I plugged in negative 11, and I got this output. When I plugged in 5, I got this output. So I hope you can tell that means we're going to have 2 points of intersection. And we got negative 11, negative 148 over 3, and then 5, comma 4. So that is the answer to the system of equations, to solving the system. We have 2 points of intersection. Okay, look at 1b. I have 3 times the quantity of y minus 4 minus 2 times x minus 3 equals negative 6. That is, I hope you're telling me, not a conic section because nothing is squared. It is a line. And then I have 5x squared plus 2y squared. So I have 2 variables that are squared, and that means, and it's a plus, so it's either a circle or an ellipse. Okay, they're not the same, so it has to be an ellipse. And when you get rid of the coefficients, you're going to find out that the 5 will be underneath the y squared and the 2 will be under the x squared. So that bigger number is under the y squared, and that means I'm going to have a, oh, that's like that. Oh, I'm going to have a big, a vertical ellipse instead of a horizontal ellipse. So I'm going to take this first equation and I'm going to simplify it down. So I have to distribute to get rid of those parentheses. So I got 3y minus 12 minus 2x plus 6, equals negative 6. And I'm going to solve that. And if you notice what happens, negative 12 plus 6 and minus 6, those all go away. So I'm left with 3y equals 2x, and therefore y equals 2/3 x. And so that's the top equation. So I hope you can tell that I cannot use elimination, and I have to use substitution. So I'm going to take this expression right here, and I'm going to go plug it into y in the other equation. And when I do that, okay, 5x squared plus 2 times that 2/3 x, quantity squared minus 53 equals 0. And when you multiply that out, you're going to get 8/9 x squared. And then I'm going to add 5 and 8/9, and I'm going to get 53/9 x squared equals 53. So I'm going to multiply by the reciprocal. Y'all probably said divide. Same thing. Okay, multiply by the reciprocal. Think of that as 53 over 1. And you're going to find out that x squared is equal to 9. So x equals plus or minus 3. Okay, what do I do now? I got to take that x and plug it back in to find out what y values go with it. So I'm plugging it in up there. And the first one I'm going to do is plug in positive 3. When I plug in positive 3, I'm going to find out that y equals 2. If I go plug in negative 3, I'm going to find out that y is negative 2. So that's going to give me 3, 2, and then negative 3, negative 2. And that's the answer to my solution. So both of these we just had 2, which kind of makes sense when you look at our graphs. All right, so that was quadratic and linear. What if I have 2 linears? I mean, 2 quadratics, my bad. 2 quadratics. So how many solutions do I have here? 0. How many do I have here? 1. And then I have 2, or I could have 3, or I could have 4. So you got to keep things straight. All right, so look at these two. I got x squared plus y squared equals 8, and x squared plus 3y equals 10. X squared plus y squared equals 8 is what shape? Okay, both are squared, and a plus sign means circle or an ellipse, and the coefficients are the same, so this is going to be a circle. And then I have one variable squared, x squared plus 3y equals 10. It's a parabola. If I move that 3y to the other side, it's going to be negative, so I know that parabola is going to be going down. All right, funky looking parabola. We'll take care of that in a minute. All right, so what am I going to do? I'm going to, if I subtract these equations, y'all, the x squared falls out, leaving me with just y's in my equation. So that's actually what I'm going to do. I'm going to go subtract the bottom equation from the top equation. And when I do, I'm going to get y squared minus 3y equals negative 2. It's a quadratic. Got to bring it all over to one side. And then I'm going to factor y minus 2, y minus 1 equals 0. And so y equals 2 or 1. So what do I do next? Again, plug it into either one, but that parabola doesn't have 2 squared, so I think it's an easier one to plug into. It does not matter. Okay, so I'm going into the bottom one, and that's going to give me x squared plus 3 times, what does y equal? Well, it equals 2 in the first one. So that means x squared is going to equal 4, and x equals plus or minus 2. So I'm going to go ahead and plug in the second y value. So x squared plus 3 times what? And that's 1, of course. So that gives me x squared equals 7, and x equals plus or minus the square root of 7. So when I plugged in 2, I got plus or minus 2. So that means I'm going to have the point 2, 2, and then 2, negative 2. When I plugged in 1, I got plus or minus the square root of 7. So I'm going to have 1 square root of positive square root of 7, and then 1 the negative square root of 7. And those are all my answers. Okay? So clearly that parabola is up there somewhere and intersecting that circle in 4 spots, as you can see. All right, last one. This is an example of our 2 quadratics where elimination, you could do elimination also, but because that's a y squared, I'm going to go ahead and use substitution. But before we do that, I'm going to talk about what this is, Okay, 2 are squared, and it's got a plus sign, so it's an ellipse or a circle. These two are different, which means it has to be an ellipse. And when I divide, the 3 is going to be under the y, and the 4 will be under the x. Bigger number under the x means that my ellipse is going to be horizontal. All right, 2x squared minus y squared equals -1. Two variables are squared with a minus sign means I have a hyperbola. The x being the positive one means hyperbola is what we call horizontal because its transverse axis, which goes through here and contains the vertices, is horizontal. All right, so I'm going to take that bottom equation and I'm actually going to solve it for y squared. So I'm going to move it to the right side and -1 to the left side, and that's going to give me y squared equals 2x squared plus 1. And then I'm going to take that and plug it back in for y squared into the other equation. So that's going to give me 3x squared plus 4 times y squared, but y squared is equal to 2x squared plus 1, and all that equals 48. So I'm going to distribute, get 3x squared plus 8x squared plus 4 equals 48. Bring that together, simplify it. I'm going to have 11x squared equals 44. Divide, x squared equals 4. Take the square root, and x equals plus or minus 2. Okay, so I got to plug in positive 2. And where am I going to go plug it in? I'm going to go plug it in where I've solved for y squared. So that's the one I'm using. And that's going to give me first, I'm going to have 2 times 2 squared plus 1 equals y squared. So 9 equals y squared, and y equals plus or minus 3. Now, when you do that again, y'all, remember it's really important to put parentheses around your negative numbers. Otherwise, when you plug that in the calculator, you're not going to get the right answer. So this also gives me y squared equals 9 and y equals plus or minus 3. So keep in mind, when I plug 2, I got 2 numbers, so I'm going to have 2 points. And when I plugged in -2, I have 2 numbers. So my points are going to be, I have 2, 3, and then I have 2, -3, and then I have -2, 3, and -2, -3. And that's all we got. So I hope that was clear and simple. Feel free to rewatch it, slow down, email me if you have any questions. Thank you so much for watching, and y'all have a great day.